Uh, Now let's come to the solution of question 2 in homework 10. Question 2 in homework 10 asks us to collect some definitions and properties of the stochastic processes. The first one is the Wildsen stationary processes. The Wildsen stationary processes is that if the mean is the constant and the autocorrelation is a function of the time difference, we will call a process a wild stationary process. Also, we may simply call it WSS. WSS we can use the WSS to do some stage estimation and some prediction in mean square sense, and also in some communication cases. We do not care about the specific value of the process. We only pay the contention on the power of the signal. And what shows the power of the signal is that the autocorrelation function. And the second question asks us to find out the definition of the independent increment processes. As we have shown in the question 1, it means that the process means that x of t1 minus x of t2 and x of t3 minus x of t4, in these two time periods, the x are non-overlapping intervals, that is, are independent. And the third one is the Markov process. Markov process, as we have learned in the information theory, that is, the past has no influence on the future, even if the present is known. And in our real world, many processes have the Markov property. For example, some discrete time and discrete state process like the binary transmission is a Markov processes. We may call it a Markov chain. And the fourth one, the normal processes. Normal process is also called Gaussian processes. That is that the x of t is normal as a set of suppose a set of random variables x of t1 to x of tn are jointly normal for n and n in t1 to tn. That is, the density function of x is equals to this expression, and we can find an interesting thing is that the statistic of the of this process is completely determined by the this mean value eta of t and the autocorrelation of the process, that is r of t1 and t2. In general, we can classify the Wiener processes, as we discussed in the question 1, as the one of example of the of this process. As a large class of stochastic process in which Werner process as a specific example. The fifth one, what is a strict stationary process is that if the statistics is not affected by a shift on a time axis, we may call it a strict stationary processes. And the sixth one, the white noises, that is for the Werner processes, if we want to if we have a derivative of the process that equals Vt, we may have the Vt equals the derivative of W of t, and now we can have the expectation of the Vt will equal 0, and the R of T1 and T2 equals alpha multiplied the delta function of T1 minus T2. The Werner processes W of t does have a derivative. We just use this as a notation. Now we need to have more discussions. The V of t is a Gaussian white noise with the expectation of 0 and the impulse correlation autocorrelation function. To define it on a stochastic processes, it will set to be a white noise if the expectation of V of t equals 0 and the autocorrelation of the process, that is RV of T1 and T2 equals some function multiply the impulse function of T1 minus T2. The seventh is the mean ergodic process. A stochastic process is set to this process is that if it meets the requirement of this expression in mean square sense.